Okay, here I've got a trig equation to solve, okay. Now if it wasn't for this 5 here, if I just had 6 sin x equals 10 cos x, then I'd divide through both sides by cos x and I'd get a tan x term and a number term, and I'd merrily solve tan x equals a number, okay. But that solution won't work with a 5 here because I'd have 5 over cos x and it would be horrible, okay. So solving this equation we can do by combining the sin x term and the cos x term, because we know that's the kind of thing we can express as our cos x plus alpha, or our sin x plus alpha, or something like that. And this thing about question 1 helping, okay, well question 1, when we look at it, was about using that r alpha method. But I'm going to actually just do the rearrangement first. So 5 equals, add this to both sides, I'm going to get 6 sin x plus 10 cos x, and I could put this, using the normal method, into the r alpha form. But let's look at question 1 now. In question 1, I worked out that 3 sin x plus 5 cos x was this, okay? And if I look at the 3 sin x plus 5 cos x, I've now got exactly double that. I've got 6 sin x plus 10 cos x, so I can just immediately go to double that previous answer that I worked out for question 1. Okay, so I've got x plus 1.03, okay, that was actually 1.0304. I could do with a bit more precision on that now, because I'm going to use that to get more solutions, so I'm going to go for a higher precision answer. So, if they're really kind, they will put this question after a question like question 1 where you'd done the r alpha method, but there's no rule they have to be kind like that. So you could see a question like this out of the blue, and then you'd have to realise that you rearrange it like this and then you use r alpha on it, and you have to be a bit cleverer. Anyhow, we have realised that, so now all I've got to do is solve this equation. So I've just got a number times sine of a bracket, so I can divide by that number. So I can do sine of the bracket, x plus 1.0304 radians equals 5 over 2 root 34. And this is just solving a trig equation, but I've got a bracket here. So in the past we sometimes used alpha to mean the contents of the bracket. I'm going to actually use t to mean my x plus 10304, because the alpha is, in the r alpha method, the alpha is something else, isn't it? So sine of t has got to be 5 over 2 root 34. Okay. Here's my set of values for x. So my interval for t, well, x plus 1.0304, I'm going to have minus pi plus 1.0304 is less than x plus 1.304 is less than pi plus 1.0304. So I'm looking at that range of values, or that set of values for t. My first t is just going to be arcsine of this 5 over 2 root 34. Okay, we're in radians. Only a fool would not check they were in radians or degrees before doing the thing on the calculator, so we get that many radians. So that's my first t, and of course my second t, well, I'm doing a sine, so it's going to be pi minus the first t, 0.4431. And then I need to compare these with my interval. Well, they're both positive. They're certainly both less than pi plus that. And if I take 2 pi away from them, I'm going to go 2 negative. So these are my only 2 solutions. So these are my 2 values of t. Okay, but t, of course, is x plus 1.0304. So I need to take 1.0304 away from each of these solutions, and I'm going to round them to 3 significant figures, because that's what we tend to do with radians, and my t values are going to be these here. And you may have noticed a bizarre error where I couldn't copy it down, but I have done the next step correctly. So those are my correct answers for t. So have I finished? Yes, now I have. Oh, except these are x values. These were t values, these are my x values. Done. Good.